Everybody, this is the velocity versus time video. So we are going to talk about the velocity as a function of time equation and the graph that goes along with it. So the equation that I am talking about is the equation that looks like v equals v0 plus at, or sometimes as it'll be written, v final equals v initial plus at. So the left side of the equation is your final velocity. Okay. This beginning part of the equation is your initial velocity. Okay. The A is your acceleration. And of course, T is time. Okay. So some important things to remember in this equation is that both velocity and acceleration are vectors. Okay, so that means we have to watch for positive versus negative. Okay, so remember, our positive directions are usually right, up, east, and north, and our negative directions are left, down, south, and west. Okay. Time is a scalar, doesn't have any directions, so that's always going to be positive. Some other things to remember is that if we start at rest, that means our initial velocity is 0. And if we come to a stop, that means our final velocity is 0. Okay. Now, with regards to speeding up versus slowing down, remember, not all negative accelerations mean slowing up, not all negative accelerations mean slowing down, not all positive accelerations mean speeding up. Okay? Remember, if we are speeding up, that means velocity and acceleration have the same direction, so both positive or both negative. And if we are slowing down, velocity and acceleration are in opposite directions, so one positive, one negative. Okay? So speeding up, we could have a positive velocity, okay, and a positive acceleration, or we could have negative velocity and negative acceleration. For slowing down, we could have a positive velocity with negative acceleration, or negative velocity with positive acceleration. So just make sure you're paying attention to the keywords speeding up, slowing down, and how the signs of the velocity and acceleration have to relate to each other with that. Okay. So with this equation, we can also get at the velocity versus time graph, plus AT. Okay, so let me write this in a slightly different format. So instead of v equals v0 plus AT, I'm going to write it as v equals AT plus v0, because if I write it like that, then it's a little bit easier to see that this equation can mirror the equation for a line. Because if it's a velocity versus time graph, that means velocity is on my y-axis, time is on my x. So I can replace velocity with y, t with an x. So that must mean my slope is the acceleration of the object, and my y-intercept is the initial velocity. Unlike position versus time, the velocity versus time graph is always going to be linear. We're not ever going to have a velocity versus time graph, at least in this unit, that is curved. Okay. So velocity versus time, velocity is a vector, so the object can either have a positive velocity or negative velocity. Positive velocity means the object is moving in a positive direction, so right, up, north, east. Negative velocity means we are moving in a negative direction. So left, down, west, south. Okay. So positive doesn't mean speeding up. Negative doesn't mean slowing down. Positive just means moving to the right. Negative, moving to the left. So let's take a look at some different graphs. Okay. So if I have a graph that looks like this, okay, this graph would have an initial velocity of 0 because it's starting at the origin. Okay. And it would have a positive acceleration since the slope is positive. And that object would be speeding up. Okay, because I am ending at a higher y value or higher velocity than I started at. Okay. An object like this would have an initial velocity that is some negative value. Okay. The acceleration is going to be negative since my slope is negative. And this blue graph is also speeding up. Okay. Because my velocity and my acceleration are in the same direction. Also, I'm ending at a larger velocity than I started at. Yes, more negative usually means less than, but in physics, the negative just gives us the direction. Okay. So this green graph, this would have an initial velocity of some positive value. And it would have an acceleration that is negative because the slope is negative. This object would be slowing down. Okay. Now, this intersection point right here, where the two graphs intersect, that represents where they have the same velocity. Okay. And then the last graph that we're going to look at, let's look at something like this. Okay, so for this gray graph, we have a initial value that is negative. The slope is positive, so my acceleration is positive, and this object is slowing down. Okay. So the last feature of a velocity versus time graph that I need to pay attention to is the area. Okay. So remember, whenever you see a graph, you want to TSA it, title, slope, area. Okay, so title is always y versus x, so v versus t. Slope is always y over x, which is why the slope is acceleration, because it's velocity over time. And area is always y times x, so velocity times time. Now, it might not be immediately obvious what that is, so let's look at the units. Velocity is in a meter per second. Time is in a second. If I multiply those two together, the seconds cancel and I'm left with a meter. So that means the area of this graph is my displacement. Okay. So if I draw a graph that looks something like this. Okay. So there are kind of three distinct sections. Right? There's this first triangular section where the object is speeding up. Then there's this next rectangular section where my object is moving at a constant velocity. And notice how the slope is 0, so there's no acceleration, so I'm moving at a constant velocity. And then there is this third section where my object is slowing down, going backwards. Okay. So if I wanted to find the total displacement, I would find the area of the triangle of that first section. I would find the area of the rectangle in the second section, and then the area of the triangle in the third section. Keeping in mind that this area is going to be negative, while the other two are going to be positive. Okay? So depending on the size of that green triangle, my object might actually end up back at the starting point, if the two areas are able to cancel. Okay. So just a quick recap on velocity versus time graphs. The slope is your acceleration. Okay. The area is your displacement. The farther you are, or the farther the graph is from the x-axis, the faster you're moving. And remember, positive versus negative doesn't tell us how fast we are. Positive versus negative just tells us direction of travel. And that is the basics of velocity versus time graphs.